Hello everyone! In today's lesson we will be studying our third lesson in the vectors series. We will study the scalar product between two vectors. So first, what's exactly the scalar product and how can we do it? First, the scalar product between two vectors is a way of multiplying two vectors here where the answer or the result is a scalar number or a constant number. That's why we call it a scalar product. And sometimes we call it also the dot product between two vectors, as it's represented by only a dot like this between the two vectors. So how can we do the scalar product? We're actually here, we have two ways to calculate the scalar product between vectors, and both are given in the IB exam booklet. Here we have the first method. If we know the components of the two vectors like this in column notation, then the scalar product will be like this. We multiply the corresponding components. We multiply here V1 by W1 and the same for V2 and W2, and then we add all of them up. So this result will give us the scalar product value between the two vectors. We will study also the second method after we have the first example. So here we have example 1. We have vector A, 5i plus 6j plus 4k, which is written in the I, j, k notation. Another vector B is given here. Find the scalar product between A and B. So first here, it would be better and convenient to write the vectors in column notation as we learned before. So now the dot product can be written like this. The vector A can be written like this, 5, 6 and 4. As we see here, we have the x and the y and the z component. Same for B. Here we have 3, 4 and negative 2. So as we said here, we will multiply the corresponding components. We multiply first 5 by 3, which will be 15. And then 6 times 4 will be 24. Then 4 times negative 2 will be negative 8. If we combine these numbers, it will be a scalar number, 31. So notice that when we multiply two vectors using the scalar product, we get only a scalar number, not a new vector. Now, this is not the only way we can calculate the scalar product. As you see here, we have another way given in the exam as well, which is this. To calculate the dot product between V and W, we multiply the magnitude of the first vector by the magnitude of the second one by cosine theta, where theta is the angle between the two vectors themselves, V and W. Here we will have an example on the second case. We're given here an example, find the scalar product of the vectors A and B. Here we don't know the components of vector A and B themselves, but we know that the magnitude of A is equal to 3 and for B it's 10. We know that the angle between the two vectors is pi over 3 radians, or equivalently 60 degrees. So if we apply the formula here, the dot product will be the magnitude of the first one, which is 3, multiplied by the second one, 10, multiplied by cosine of the angle between them here. Now, cosine pi over 3 would be half. So here we have half times 10 will be 5, and 5 multiplied by 3, so the answer here will be 15. Now let's move on to the angle between two vectors. Here, as you see, we have two vectors V and W. This is the angle theta between the two vectors. Now speaking of angles, do you know that the scalar product can also tell us about the angle between the two vectors? Here, in this formula here, if we rearrange it to make cosine theta the subject by dividing by the magnitudes of V and W, we will get this formula here. Cosine theta is equal to the dot product or the scalar product between them divided by the product of their magnitude. Now we will have example 3. We need to find the angle between the two vectors. As we see first, we need to calculate the dot product or the scalar product here. So when we calculate it, A multiplied by B will be, first we multiply 5 by negative 2, which is negative 10, then negative 4 multiplied by 3, which is negative 12. 2 by 6 here will be plus 12. We can cancel here. So the scalar product would be negative 10. Now we need also the magnitude of each vector. So first, the magnitude of A, as we learned previously, it will be the square root of the sum of the squares of these components, 5 squared plus negative 4 squared and 2 squared, which will be the square root of 45. Now the magnitude of B similarly will be the square or the sum of the squares of these. So we will get here the square root of 49 here, so that will be 7. Here we apply in the formula now. Cosine theta will be the scalar product here, which is negative 10 divided by the magnitude of A multiplied by the magnitude of B. Here, if we find the angle theta using our calculator, we will have 102.3 degrees. In the calculator here, we can just do that. Theta is equal to the inverse of cosine, negative 10 divided by the square root of 45 multiplied by 7. It will be here 102.3 degrees. Now let's move on to some properties of the scalar product. Here we have the cosine again here in the formula. So here we have three cases about the sign or the answer of the scalar product. First, if the scalar product is positive between the two vectors, that means the angle between them will be an acute angle between 0 and 90 degrees like this. So here, as you see in the fraction, the magnitude is a length, which is always positive. So if the scalar product here is also positive, then the entire fraction will be positive, and then cosine of the angle will be positive, which means that the angle will be in the first quadrant between 0 and 90 degrees. Now, what if the scalar product is 0? Here we have a very important case. If the scalar product is 0, it means the angle between them will be exactly 90 degrees and they will be perpendicular vectors. Because if this is 0, as we said, it means cosine theta will be 0 and therefore the angle will be 90 degrees. This is, by the way, a very important idea to prove that the two vectors are perpendicular. The scalar product between them will be 0. So if we're asked to find or prove that the two vectors are perpendicular, we can just prove that the scalar product is 0. A third case here, if the scalar product is negative, then here we will have negative divided by positive. So cosine will be positive, which means the angle between the two vectors will be an obtuse angle in the second quadrant between 90 and 180 degrees like this. So if we go now to our previous two examples that we did today, here, as you notice, when we did the scalar product between A and B, it's 15, which is positive. That's why the angle between the two vectors is acute. It's here 60 degrees or pi over 3 radians. But here, when we multiply the two vectors, the answer is negative. It's negative 10. So that's why here the angle is obtuse, bigger than 90 degrees. Now let's move on to example 4. Here we have a real question from past papers. We're given two vectors A and B in terms of k, where k is a real number. And we're given that the two vectors are perpendicular, which means the angle between them will be 90. We need to find the possible values of k. As we said today, if two vectors are perpendicular, it means the scalar product between them must be 0. Which means now the product between the two given vectors A and B must be 0. Now here we will calculate the scalar product. We will use the formula here. We'll multiply the corresponding component. 2 by negative 3 here will be negative 6, and we multiply k by k plus 2, which is this. We have here negative 1 times k, which is negative k. We can expand here to simplify the equation. We will have here k times k, which is k squared, k multiplied by 2, 2k. If we simplify further, we will have this quadratic equation. We can simply factorize this quadratic like this. We need two numbers add up to 1 and multiply to -6. They will be 3 and -2. So we will say here either k plus 3 is equal to 0, and that means k will be -3, or k minus 2 will be 0, which means k will be 2. So these are the possible values of k.